a one-stop solution for protein analysis and antibody selection. I'm Tony Zhong, the CEO of Instant Biosensors. And our BD head, Emily Liang, is also joining the webinar. So if you have any question, please leave your message at the Q&A message. We will try our best to reply to you. So let's start our webinar today. Okay, it's a great honor that we have this moment to present in our company product and technology. We believe light can save life. This is our vision, and the mission is to become the pioneer and leader of biomarker solution provider from the analysis to the diagnosis. So today I will cover two sections. One is analysis. The other is diagnosis. Some great news just for you to know. We've been selected from the Merck Innovation Center as one of the Asia innovative company. Actually, is selected from over 500 biotech companies globally. So as you can see, the website here that mention about our company at the Merck website, and you can scan the QR code here to understand more about the detailed things. So today I would like to mention about what does the Instant Biosensors overcome the problem in at this moment. As you can see, we go to the hospital because the sick care of the disease. So in the hospital central lab, we have the invasive, also the to do some lots of the checks, like blood, they check over the brain image to do those other checks. But as we know, these kind of the sick care and that disease, just like an iceberg. The iceberg which is this big, but up the like water, as we use the conventional detection, just like an ELISA, we only can see these upper iceberg. But for the deeper of the iceberg, it's really hard to find. We only can use the aspect, how the deep and how the widely of the iceberg. So it's pretty hard to use the traditional like immunoassay like ELISA to do the experimentation. So according to the reference, there's a 75 of human protein are difficult to detect because of low abundance. So the low abundance will be a problem that for the scientists and also for the hospital clinician to understand their research and biomarkers. So as we know that we always talk about like non-invasive and early diagnosis. So through the tear or like a fingerprint, blood, or the urea, and lots of the way that we can detect those non-invasive and early diagnosis. So that our technology for the ultra sensitivity detection is greater than 1,000 to 10,000 is better than ELISA. And also the wide linear range is covered, is up to 5 orders, which is low concentration to high concentration. So we'll help the scientists to understand whole the picture of the iceberg. So that's our purpose. So if we can do the very good analysis first, and then we will have a very good high performance detection. That's what we are doing now. So we have a couple information just for you to know. First, we are the first in the world use a licensing. Licensing is combined optical fiber, narrow technology, and also the microfluidic. And we have a global patents, over 40 global patents distributed in UK, US, and the mainland China and Taiwan. And also now we have a new patent now, and we booked in 2021, Japan, also Korea. And the leading publications that we have 25, but this year we're up to 30 patents. What is our core technology? Our core technology actually is combined FOPR and also the in-chip. What is the FOPR technology, which is the fiber optical particle plasma rhythms? As you can see, this is the optical fiber. So optical fiber, we coding with a narrow particle. So the narrow particle are immobilized with the antibody. So once the light source like pass through into the optical fiber, then we can sense the intensity change, and then we can do the analysis and also the detection. So we have another global patent which we call is in-chip. In-chip is a auto-folding chip. As you can see, once we pipette in a sample, and you just do it just auto-folding, just like this. And then once the sample folding in, and then once the light pass through, and we can detect the sensitivity change. The benefit of this in-chip is low. There's a very low sample loading, and sample requirement is pretty low, and there's no need to have the pumping and tubing and the vest. As you can see, the other instrument here, the optical design is always an issue. I've been in the field around 20 years. I think the fitted Korea also sold a lot of the equipment. So inside the equipment, there's a very complicated things. For example, like optical design and also the folding system. So the optical design, as you can see, inside is like a hard lamp or laser excitation. And the detection module is the EMCTC or PMT or CCT, these kind of a complicated optical design. And for the other side is inside there's not only the optical design, but also the folding system. Once we fold it in, like our blood sample or serum or plasma or urea, this kind of sample, the inside is always like a pumping, tubing, this kind of a very complicated things will increase our after service loading. Okay, so we have a two-part. One is analysis, and the other is a detection. For the analysis is focused on the life science field. So that we're focused on the antibody drug, antibody antigen selection, or vaccine development, and the biomarker assay development, those kind of things. And for the detection, we're focused on the diagnostic things and also the monitoring these kind of applications. And then our plan is to do the deeply analysis before to choose the assay methods. As we can see, lots of the assay methods, for example, like ELISA or the FAST3 fast test or the POCT. So we will highly recommend to do the deeply analysis. For example, like the antibody and the antigen selection through our analysis, like affinity and the epitope binding, and also the database analysis. And then we use the buffer selection to help the scientists to understand their buffer is help the antibody or antigen to become more stable or not stable. And then through our machine, a licensing biomarker analyzer can also get those of a limited of detection and the linear dynamic range. Okay, first we go, the first part is the analysis. The first part of biomarker analysis through our licensing biomarker analyzer and based on the FOPR technology. The first question to all of you, why we need a FOPR analysis before analysis? Why? I think that we all do a lot of email works. For example, like ELISA or do a lot of the biomarker assays. When I go to the Boston and visit Harvard and Brigham Women's Hospital, their clinician, they do a lot of scientist work. I ask them why you pick up the these kind of antibody, and why you use these antibody to become your downstream work, and then just reply me, okay, it's my doctor let me ask me to use that. That's the first, and then the second is I just follow the paper, and the third from the research assistant is this antibody is the most expensive one, so I pick up this antibody because it will help me to reduce those risky things. Okay, so but we are all scientists, right? So we should run it through as a scientist way, and not just like pick someone's what says so and so, right? So how we reduce like a time, how we have a very good selection of specificity and sensitivity, and how we to pick up those of the good wild linear range things. And we run through the immunoassay or ELISA things. We do know their affinity before we run through those experiments. And am I have a wrong or bad buffer selection before we apply our ELISA assay? If we all understand these kind of information, that will reduce. We will have and also improve our assay development and reduce those of money waste and also the time waste. That's what we can. Okay. Now we go to the laboratory work a little bit. I think we all familiar with the NGS, next generation sequencer. As you can see, we do use the nail drop, qubit, or the biomarker analyzer to identify those concentration size, these fragment things. Because we know the NGS costs a lot. So we do a lot of the quality control before we apply to the downstream experiment, like NGS or real-time PCR. Okay, let's go back a little bit like a protein assay. You know, I've been working in the field around 20 years. I know that lots of scientists, they use the ELISA to do an analysis and also use the ELISA to do the detection. So how come the analysis through the ELISA can have a deeply analysis? So no wonder our experiment always the West time and West month, right? So this is our statement. To do a good analysis through our licensing biomarker analyzer to deeply understand those affinity things, epitope binding things, and the stability things, and then go to the downstream ELISA or the fast tree strip develop. That's what we are highly recommendation for that. So how we do this kind of experiment? As you can see, if you can see the video, the chip just this big size, okay? So we just put it in. This is the blank chip. The blank chip already have the fiber sensor. The fiber sensor already have the nail particle. So we immobilize the antibody onto the fiber sensor. So as you can see, when we load in the antibody, we can directly see the real-time signal. So it's quite easy to understand. Am I immobilized? My antibody is good or bad? Okay. So for the ELISA, you never know. Once you have a result, then you will know you failed the scan, right? Failed this experiment. But through our licensing biomarker analyzer, you can do is know the immobilization is good or not. And then before you go to the downstream analysis detection. So the first, you load in the antibody, and second, you load in analyze to do the deeply analysis. And then once the affinity or the detection is good, you will see the reduction curve here. And if there's no affinity or no any response, then you will see the flat signal. So let's go to the downstream analysis. So the SEN use a fiber sensor and with the antibody, and we load in with the 5 different concentration of the analyte, step by step, one by one, okay, with the SEN chip, okay, loading with the 5 different application concentration. And then we put in those data into our analysis software, and we can see, and we can analyze those affinity, stability, and for the other application later I will mention is affinity, epitope binding, and those kind of like LOD and LDR, these kind of information for you to know. So let's go back a little bit and to describe what is affinity things. So the affinity is, first, is how fast does these things happen? So which means the association things. How fast the molecule binding together, that's the first. And the dissociation is, after the association, how fast complex fall apart? How fast does the molecule dissociations? So these two, K on and K off, will help the scientists to calculate the affinity ability. That's the affinity is. I think you're all familiar with this, but I would like to mention if the antibody affinity locate on the class 1, which means with the best of the specificity and the best of the stability, okay? If they locate on the class 2 or class 3, which means we need to adjust their buffer system to make the stability move to the class 1. That's what our suggestion. So I'll give you an example. The example 1 is we the customer select the commercial kit. The antibody and the antigen all both from the INB system. And then they use an APCAN antibody to compare with the INB system. Okay. You might say, oh, it's an unfair game, right? The unfair because all of the antibody and the antigen is so already commercialized by INB system. And APCAN, they might be lose this game, right? So we all put these two chips to identify, to do the analysis. And we get the INB system, their performance, K on, K off, and also the liberty of the detection or linear dimer range here. We find one of very interesting part is APCAN, they have a better performance at the affinity part. So we go to the 3D analysis. We can see here, the APCAN here, they have a very good performance. They have a good K on and K dissociation numbers, so that locate on the class 1. But on this system, we might think that they have a very good commercial kit, but actually it's not, right? There has a very good specificity, but their specificity is not that good. Their stability is not that good. So no wonder that on this system they use they need to use their buffer system and to move to the class 1. So that's what we identify that. So we also use the affinity database to help the scientists to understand, am I located on the class 1 is truly the best choice, because we have the affinity database to help the scientists to identify which affinity is the truly a good affinity for the analysis. And then the other example for you to know, these are all truly case for you to know. One of the scientists, they use a PBS and also their recipe of the ELISA to do the analysis. As you can see, the first they use a PBS, and then they use the ELISA, their buffer, okay? Their buffer, which help the scientists to improve those kind of the KD, become the better of the result. So we'll help the scientists to use their buffer system, use our licensing biomarker analyzer to select the best of the buffer and also help the buffer develop. Okay. The other applications for the FOPR analysis is epitope binning. I know some of the scientists that you have the experiences use the like ELISA or use like a faulty buyer or beer code. But our FOPR analysis, we have a one pair, which means the antibody one and to check the other antibody. But for our assays, a little difference is we put all the 4 different antibody together one by one to identify their interactive between and also the relationship between these 4 antibodies. Let me describe more detail about that. So this is the one of a company in Taiwan that use our epitope binning and also our system to develop their COVID-19 antigen rapid test. Okay, what they are doing, what they use our epitope binning FOPR analysis. First, they immobilize their antigen here, and then they flew through antibody 1, antibody 2 or 3 step by step, right? And then they would like to see different antibody step by step to identify which epitope can be recognized for the others. Okay, so as we do this is step by step. First, we load in R21 antibody. So we can see definitely these R21 can bind onto the antigen, right? And then the second E40, they load in the second antibody, and you can see also the reduction signal, and also the E5 can have the same, which means these are the 3 antibodies that recognize different epitope. Okay, that's the totally different than the previous like vehicle or other technology. So we will see these 3-dimension and the relation interactive and relationship between these 3 antibodies. And then we keep going and to analyze the other like E30, 36. And you can see R21 loading with the, after then we loading with the E33, and then the signal is flat. So we understand the E21 and E36 is use the same epitope. So based on these epitope binning map, we can select the best of the antibody pair. That's what we're doing now. So we have the other example for you to know. This is an ongoing project. This is not finished yet. But just for you to know, first we pick up the commercial antibody from the like AppCan, gene test, and lots of different antibody. So this kind of information, first we do the affinity analysis. And secondly, we use these different antibody or to do the epitope binning. So we find out the NFL, the best of the combination is G2 has a close relative with the same epitope with the G1 and G3. So we will not use the G1 to become a pair with a G2. So we might use the G1 and G3 as a pair. That's what we are doing now. Okay. So what kind of a sample type that can apply to our FOPR analysis? There's a couple of things that we use, like the DNA, epitope bin, aptamer, or antibody antigen, these or peptide. These kind of some of the scientists that use for the sample type for the epitope analysis. And then because we already go into the antibody ecosystem, so there's a couple way that we do, because the Emily is managing these kind of relationship, and also the business developed with the AppCan, Israel of the Postback and Merck, and BioLegend, GeneTech, Legend, this kind of company, and help use our platform to do a lot of the antibody selection of those kind of things. And also instant nano biosensors, we have our own antibody. Actually, we do the affinity analysis to help the scientists to do the high quality control before they use our, before they select the antibody. Okay, and then secondly, we will go to the second section. The second section, after we do the deep learning analysis, and we will use our detection system to do the deep learning analysis. So we go to the biomarker detection. We have two machines. One is a benchtop device with 2 and 8 channels, and the other will come in the next next year, and then we have a POCT device. And what's our benefit? As you can see, the benefit we compare with the other US brand device, which is like a Quanteness MSD or the ELISA Dynas. For these of a company that will not reduce those of the steps. Okay, we still use the automatic like a liquid handling to do these kind of complicated works. I think if I ask you one of the questions, do you like to do the ELISA? I think definitely it's not, right? For me, I don't like to do the ELISA. So that's why we developed the instant nano biosensors system. That's one of the reasons. So we only need a couple steps, and within the 15 minutes can do the analysis. And also, we focus on the detection will help us, the scientists, to save the time and get a result. Okay, you might say Quanteness. I don't know who know the Quanteness. If you know that, you can raise your hand. There's a downstream. There's a raise your hand icon that you can put there. Okay. These kind of big machine actually is good, but it's too big, just like a refrigerator. Okay, in our house, right? So the Kevin actually their CEO. The CEO mentioned about because the pandemic, the COVID-19 issue. So they are looking for the decentralization detection methods, and also can keep the ultra sensitivity down to femtogram per milliliter and has a wide linear range. The Quanteness is pretty good. They have a very outstanding performance, but it's too big. So they are looking for the desktop, benchtop device, and with a simple and easy handling these things. So for the instant nano biosensors, we reach these outstanding performance. We can use not only for the analysis, but also we can do the directly detection without the sandwich, without the pair. We only need one antibody can achieve these outstanding performance down to nanogram per milliliter and also picogram per milliliter. And then for the sandwich assay, we need a pair assay. So after the analysis, we pick up the best of the pair. Antibody 1 for the capture, and antibody 2 for the detection. And that's what we are doing now. And then for the small molecule that we can use a competition assay. Okay, these are 3 of the methods and also the analysis. We have many publications and leading publications. This year we are up to 30 leading publications. And some of the applications that been published our cooperate with these of the scientists. I'm not going to step by step and one by one to introduce these. Okay, I will first introduce one of the directly detection. The direct assay is a fiber sample use immobilized antibody and through the analyte. Okay, we use the means flu. The means flu detect the TNF alpha. Okay, so we compare with the ELISA. As you can see, once we compare with ELISA with a narrow dynamic range, and we have a broad of the dynamic range for that, and that's for first. And secondly, as you can see, the MMP3 here, the narrow dynamic range is for the ELISA. we have a wild time range, also the sensitivity is good. And then we use the ultra sensitivity is for LISA ASIC. But for LISA ASIC can down to femtogram per milliliter, can achieve these outstanding performance. The publication here, I don't mention these, but as you can see, these kind of combination can help the scientists with a very good performance of ultra sensitivity. I use one of the example for you, the brain injury example for you to know. We detect the GFAP. Normally we use invasive, also use CT, MRI to do the downstream analysis. So we pick up first to select the best of the antibody through our analysis and also the epitope, and to confirm that because we use the AppCam. So that's the reason next week AppCam will invite us as a keynote speaker to have a speech to their customer. We use their antibody to do the comparison with our analysis. The same performance, just what you saw here. Same antibody here. The antibody that use ELISA with a very good limit of detection down to 3.5 picogram per milliliter. But the limit of the dynamic range is not that good. So as you can see, our antibody antigen with a very good performance of 3 femtogram per milliliter and with 5 orders. So if the scientists would like to have a highly performance of the antibody, these kind of a combination, that can use our licensing biomarker analyzer to do the analysis. So these are a couple of information just for you to know. And then we compare with the ELISA, Sinova, Quantanis, the data. So different application company show that we have the best of the limit of the detection and wild dynamic range. Also, the running time is the only couple of minutes. So we provide a highly performance compared with the other 3 different companies. So just to summarize the product and service, just for you to know, we provide the service and we provide the equipment for the whole solution of a package. So if you would like to have a project, we do it step by step. Is use the antibody to do the candidate validation to understand how the picture of the antibody antigen, and then we go to the data analysis and together with the scientist and to do the detection after the analysis to do the good performance of detection. And then we can do the out licensing globally and we can do the commercialization. Yeah, we have a couple corporate customer and scientists just so you to know. Yeah, so thank you for your participate and thank you for your time. We believe a light can save life. And please leave your message on the Q&A section. Thank you.
Okay, thanks, Tony. And this is Emily, the BD manager at Instant Nano Biosensors. And actually, we have an activity. We want to vote your thought. So before I start this vote, I will switch, including Sohin. Sohin, yeah. So including you. So I will switch your tendency as the participate. So and then you can vote. Okay, so hold on for 3 seconds. Okay, so I'm going to start a vote session. Okay.
I think they're all there, right?
No, they are still here. Okay, so I believe they show something there. They have 3 simple and quick questions regarding after the talk of Tony introduced about the FOPR technology. What kind of analysis the FOPR technology are you interested in? Please vote. And this is could be as the double or triple or even all of them is no problem. So please click that which item you are interested in. For example, for the LOD or LDR or even the affinity ability or the affinity database or apto binning. Okay. So the second question is, what issue of detection do you think important if you are doing ASIC development? For example, if you are doing the antibody drug develop, what item is you are think it's important? For example, for the sensitivity down to nanogram or picogram is good enough, or you want the ultra sensitivity as femtogram, or you want the wide linear range around 5 orders, or you think the ability of detection small molecular or ability of detecting nucleic acid. Okay, so the third one is, are you interested in knowing more about FOPR analysis and detection service? Okay, so we will start the vote after 10 seconds. And we can have a short music. Okay, so we finished the vote section. Okay, so we can go to the next session for Q&A, and that is welcome. If you have any questions, use in Korean language is no problem. And then Hisam will translate for us. Okay, so I think we have the first one is, when I use crude X-ray by analyte, should I go through a special process? Tony, this is the first one. First question. Okay. I think it's regarding about the analyte item. Should they need any extra extraction process, or it's fine for directly to use on our system?
Okay, actually the sample should be like a pure. Yeah, for the analysis should be a pure, like antibody antigen things. If there's too many extraction, those kind of things, they will affect the analysis performance. That's for my recommendation. So at least analysis part is for the keep simple as possible. Yeah, that's my recommendation. Yeah.
Okay, thanks, Tony. And I think we have another one. This question is, let me pass in the type room. Here is the question is, what is the difference between FOPR and SPR system for apto binning, especially for apto binning?
Yeah. Yeah, for the apto binning, I think for the 1 by 1, they do the if you do like you want to do the screening, you have like maybe about 100 or 1,000. I will recommend that you go for the beer code. Okay, we do this deeply to understand the candidate. After the ELISA or for the beer code, you will select around 5 to 10. Just like the company here, they have 20. So we do 20 different analysis or to do to identify the relationship between those of the up to 2 or 3, these kind of epitome binning thing. That's why we different than beer code. Yeah, for beer code, they only can put the 2 together, right? We can up to 3 to 4. These kind of interactive relationship, and to see what's the truly like epitome binding scenes together. That's what we are different than vehicle. Yeah. Okay. And for the, I don't know if you're familiar with like a vehicle. I would say that for the a vehicle is like you just like a binding line. If you can see my hand here, okay. Let me share. Okay. If you can see my hand here, okay. Vehicle just like association, right? And our system is gently association to see their original binding capability. But for the vehicle, is like a least kind of association. They use like a strongly buffer to try to dissociate these out. Okay, so will be a little different. Our system is gently association and gently dissociation to find a truly affinity performance. Yeah, that's another things to share with you all. Thank you.
Okay, thank you. So Tony, we have several questions there. I think it's collect from Hisam. So anyway, I think I just picked few. One question is how to block the gold surface. How to block that? Just use common block reagents such as BSA or casing. How to block?
The block, which means you would like to reduce those like non-specific binding issue, right? That's what you asked, right? Yeah. So we do not use we do because our chemistry team is quite strong. So we do use a couple ways. One is in the past we do use the BSA, but now we do the combination buffer is to help the scientists to reduce those non-specific binding. That's the first, and also that for the detection part, we would like to optimize those performance. Okay, optimize those assay devices. So we will use not only the chemical or buffer system to reduce those non-specific binding. That we also use an algorithm to identify and to calculate those signals. So we use a two combination to achieve these things. And also if you want to do like, for example, like do the ultra sensitivity things, that the FOLISA assay will keep the and reduce those kind of the matrix effect, those kind of information. Just a couple of information for you to know. One is the chemistry, the other is the algorithm to overcome the non-specific binding. Yeah.
Okay. So Tony, one more question. I think we can finish this session. So the last question is no pumping. Yes, yeah. I think the no pumping means, what is the no pumping means? Can you explain more to the attention?
No pumping means when you pipette. For example, like as you can see, inside there's a pump, syringe pump, right? And also the tubing things, very complicated inside the other machine, right? For us, we just the chip here. So you just load it in through the, you just load in pipette in, and then our the microfluidic things will through those liquids automatically. Okay, so no pump means there's a no pump device or module inside our machine. That's the first, and the other thing is once you just pipette in, then the liquids flow in. That's what we doing now. Yeah.
Okay.
Is that okay?
Okay, thank you, Tony. So I think we still have the questions. So Hisam, do you have time? It's okay for one more. Okay. Yeah. The last one is one of powerful thing of ELISA is throughput, right? So ELISA can produce hundreds data in one experiment. What is your opinion on this issue?
Okay, that's a very good question. Okay. ELISA is for the screening purpose. So if you want to, but ELISA have some limitation. Limitation is the sensitivity and also the dynamic range. For the absorbance, luminance, forensics, and those kind of the things, that only the dynamic range just like here, right? And then our dynamic range is up to is the wild dynamic range. So that means, as I show you these kind of the information for you to know, the deeper things is ultra sensitivity. But for the ELISA, only can see like maybe like a microgram or nanogram things. They cannot see the deeply things. For us, if your application is you don't need like a non-invasive, you don't want early phase, you don't want to see the ultra sensitivity, and go ahead for the ELISA because that's the already is a good solution for that. But if you want to have the ultra sensitivity and also you want to do like an immune response detection, for example, what is the immune response? For example, like you inject the protein drug or the cell surfaces, then the patient their immune response will getting higher, right? Getting higher means you need to dilution those of the original serum or plasma. Otherwise, you cannot get those data, right? So you do the dilution. So for us, our is the ultra sensitivity and also the wild time range. But for the ultra, like 1,000 or 100 these kind of sample, and you just want to screen, then go ahead and use the ELISA. But you want to just pick up the very specific, unique. For example, like we have the brand into these kind of very sexy application that you definitely use our FOPR technology. That will be a little different. It's so highly react to your applications. Yeah.
Okay. Thank you, Tony. So let me pass the time back to Hisam.
그러면 지금까지 인스턴트 나노바이오사의 웨비나의 마지막까지 참여해 주셔서 감사드립니다. 질문이 있으시면 이후에 지금 설문지라는 송부 드릴 건데요. 해당 설문지에 질문 작성해 주시면 감사드리고요. 그리고 당사 홈페이지 질문 게시판에 남겨주셔도 답변 드리도록 하겠습니다. 그리고 해당 영상은 이제 피코리아 테크놀로지 유튜브에 업로드할 예정이고요. 피코리아 테크놀로지에서 주최한 다른 웨비나 또는 영상들도 많이 있으니 유튜브에서 피코리아 검색 부탁드립니다. 지금까지 본 웨비나 참석해 주셔서 감사드립니다. 그러면 다음에 또 뵙겠습니다. 감사합니다. Thank you very much.